After we done generating the bitstream, let's open our SDK so we can start to test out the code of the poll mode and the interrupt mode in order to understand the concept more clearly. Let's wait to open the SDK. Okay, now the SDK is still initializing and we need to wait for a little while. The initializing has been finished. Now we can create a new application and we choose application. This is our name. We will use OS platform, which is standalone. It means we don't use any supporting operating system. We will use bare metal application. Our application will be almost bare on the hardware. And then we go to next, we choose Hello World, finish in order to create a good project folder. So after we create the project folder, you can see there's the system.mss. So in the system.mss, we will see the GPIO. In some case that you close it accidentally, because this file is very important as a reference, you can go to the app PSB and we double click on the system.mss, and here we can import the examples. Our example, the poll is really easy, but if you want to have some example for the interrupt, you can click on it, or you can click on whatever. I will choose to example, and we click OK in order to import those examples into our Project Explorer. And now we wait. Okay, now the examples are imported successfully in our Project Explorer. We can have a lot of, here we can see 1, 2, and 3 independent applications. We can run them independently on our board. Now let's check our board. The board is, here. So our board is not on. Let's turn it on. Now the board is on. We can first program our FPGA. And then we will connect our SDK terminal. Go to SDK terminal, connect to the COM, which is connected to our board in order to see some messages sent from the Zynq chip to our computer for the debugging process. And after that, we will choose the application we want to build, and we choose build. And then we will launch this application, run as, and launch on our system, Zynq chip. Now the launch has been successful, and we can go to the SDK. And there's a LED blinking due to the XRTL example number 1. Now let's build this application, another application that we imported, and launch it to see what will be the difference. Yes. And go to the SDK terminal. You can see this is the message sent from the Zynq chip to our terminal based on the instruction of this imported example. So everything looks good. We can after we import them and we feel that okay, we read enough references from those examples, or we try enough, we can delete them from our Project Explorer by right click, choose delete, and we will delete the contents on the disk. It's fine. It's only delete the content in our project folder, but the root file where we imported in still stays. So don't worry, just delete them on the disk. Now let's go back to our application. We choose the hello world, right? Maybe we can change it to first rename, change to poll and interrupt. Now let's open it. You will find the code in the link that I put in the video description, so don't worry. First, I will just copy the code from the poll mode into our SDK. We will have a little bit of explanation, and then after that we will try to run it in order to see. So this poll mode code will have to combine with our diagram. Let me open the diagram. So now you can see this is the flow diagram of our main program, right? And this is our main program. The main program is oh, sorry, I copied the wrong code. It should be in the mode, in the poll mode. Oh, I think I made a mistake that I override my poll mode code. Okay, let me check and I will come back. So sorry for the mistake. Now I already modified the code for the poll mode. Now we have the code for the poll mode. Okay, if we look at the flow chart here, we will see that this is the flow of our int main, of our main program, which will follow the software flow that we have in the concept introduction. So the first step is to initialize and set up our XGPL for both channels. We have only one XGPL, which is the GPL 0, and the channel 1 is the LED channel, and the channel 2 is the switch channel. We will set the LED channel as output and the switch channel as input. And here comes the while loop 1 as the flow chart here, and the first task is to read in the switch value. So we will directly poll the switches, mean we will ask or we will command our switches directly inside our int main. We will still use, you can see we are still inside our int main in the main program, the main function. So we read in the switch value and then we will blink the LED 5 times according to the switch value. And after we're done with the first task, we move on to the second task of blink the fourth LED. So you can see I turn on the fourth one and then I turn it off so we can blink it, and I put it in the while loop 1. So this one, as the software shows, will have to continue for infinitely time. Now let's those are the only supporting function that we need to use. In order to understand them, how to configure things, please refer to my embedded system on chip part 1, 2, 3, and 4, so you can understand. Of course, there will be some changing that, like, I will abstract some steps in order to put it in a function, so it can be easier to use. That's all. But the steps are all the same. So now I will build my application, and then I will launch it on the board. Now I will have to open the board so we can easily observe the behavior of the board according to our code. So, and also don't forget to look in the SDK terminal. SDK terminal and the board, they will be the two main interest in order to clearly understand things. Now I import my application on the board. Okay, so now we are blinking the LEDs according to the button, because both of the buttons, both of the switches are on. We are blinking the LEDs according to the switches. Both of the switches are on, that's why they will blink the first and the second 5 times according to the task, and after that it will change to blink the fourth LED, which is the second task. So it really does things in order. You can see that after blinking 5 times according to the switch buttons, according to the switch pattern 5 times, it will change to blink the fourth LED as we defined in our while loop in our main program. So now let's change the switch. I will change the switch to, I will turn off the first switch. So you can see it only turns on the LED according to my switch pattern. And if I turn both off, and you can see there's nothing on because it's doing this job, and nothing on, so no LEDs are on. And you wait after 5 times, it will blink our fourth LED according to the second task. So that's the second task. That's the second task. Now if I turn on the switch number 2, I will expect to see the LED 2 blinks 5 times, and then after that we'll do the second test of blinking the LED number 4 here. And it's true. Now we will turn off the second switch and turn on the first switch. So I will expect to see this LED blinks 5 times, and after that it will change to the fourth LED according to the second task. So that's how the port mode means in programming. Now we will move to the interrupt. So I will copy the code from the interrupt. As you can see, it's not so different according to our demonstration in the part 4 or part 3 of the SDK of the embedded system that I made earlier, but the interrupt will be significantly different. So let's see our main program. This is our main program, and let's see the flow of the interrupt. So this is the flow of the flow inside our main. First we need to set up our excitorial. This is here. And second, we will need to set up the interrupt service. So for the interrupt service, we will need to set up the generic interrupt controller in our processing system. And after we set up that GIC, we will need to set the priority and the trigger type of our interrupt ID. So the interrupt ID means the interrupt where it comes from. So here I define the interrupt ID. If you control click, you will go to the definition. And this one is defined as our interrupt ID of the GPIO 0. The interrupt from the excitorial 0. So we need to set the priority of this interrupt ID and also the trigger type. This will be the number to identify the priority of our interrupt ID, GPIO 0. And this one is the value to indicate whether we want to set our trigger type as the level sensitive or edge sensitive. If we put the binary of 0, 1, then it will be the level sensitive. However, here we put B11, so it will be edge sensitive. rising edge sensitive. And after we define the priority and the trigger type of our interrupt ID, again the interrupt ID, it means identify the interrupt signal between our TIC, the generic interrupt controller in the processing system, and the block in the programming logic. In our case, is the XRGBO. So that connection between the XRGBO and the GIC in the processing system with the interrupt signal is called the interrupt ID of that block. And after we set the priority and the trigger type, we will have to connect our GIC. So the interrupt instance means the GIC. In this case, we need to connect our GIC to the interrupt ID and to the subprogram or the interrupt subprogram routine here. We need to connect this subprogram and routine to our GIC and also the interrupt ID connection. This is the name of the subprogram or the routine for the interrupt generated from the block XRGBO0, and more specifically is the switch itself. The switch connected to that block. And after the connection, we need to enable our GIC. We need to enable the interrupt ID connected to our GIC. And after enable the connection in our GIC, we also need to enable the interrupt in the GPIO itself. So here we enable the interrupt in the GIC in the processing system, and here we enable the interrupt in the XRGBO. So that are the steps in order to set up our interrupt service. Now come to our main while loop. So here is the main while loop. You can see first we need to blink the fourth LED, and here we blink the fourth LED. And after that, we will have to check a shared variable where we defined as a global variable. You can see this is defined here outside our int main, so it's considered as a global variable. And we will check that variable. This variable will be modified by our subroutine, even though I don't specify in the subroutine, since it's not too important in this case in order to understand the working of the interrupt system. So that's why I don't put it in the subprogram routine. However, we need to put in mind that this value will be modified by the interrupt subroutine. And if there's no error from the GPIO0, we will print our switch value inside the loop. We will print the current switch value in our main program. And if there's some error, we will print the error inside our main program too. And then we come back to the beginning of the loop, because this is the infinite loop. So you can see this is the end. This is the end of my int main. There's no place that I perform the task of reading in the switch value and blink the LEDs according to the switch value read in. This task is defined outside our main program. So here is the main program. That task is totally not inside, and I define that task here in I define the task here in the subroutine of the interrupt. This task, you can see this subprogram or the subroutine is tied Control F, and you can see V here and here. Here is connected to our GIC and also the interrupt ID. So that's how we can connect the function outside the main in order to be programmed in the file. So this subprogram is also in the same file. So this is the file. This is the file poll.interrupt.c, and the int main is here, and also the subprogram is here too. The subprogram is here too. Now let's see the subprogram. I would, as the subprogram already determined, there will be the pointer, the instance pointer, and because it is tied to the instance where the interrupt signal is generated. In our case, it's the x0, so for sure this instant pointer should be the same with our GYL0. So it's gonna be fine. I will, whenever this interrupt subroutine is entered, I will print out a message that we are inside the subroutine. And when we are inside the subroutine, we will do the task here. We will do the task of blinking the LEDs according to the read-in switch value 5 times, and after that we will get out of the interrupt routine and be back to our main program. And you can see the flow of our main program will be interrupted by the changing in the switch. So now let's clear the SDK terminal and we will build the application and launch it. Now let's look at our board. So the LED blinks here is because we perform the blinking of the LEDs. That's why it blinks. But you can pay attention, there's no blinking of the LEDs according to our switch button. Sorry, our switch button. There's no linking the LEDs according to the switch button at the moment, since we don't do that task in our main program. We are in the main program. So that's why we don't do that task. You can see the switch value is inside the loop because we set this value to be 0 at the beginning. So now we just keep reading in the switch value in the while loop 1 here in the int main, and we don't do the task. Now let's jump inside our subroutine by changing the switch. So even now you can see that we are inside the subroutine, then we outside. After 5 times of blinking the left button, we are outside the subroutine and we back to our while loop. Now let's jump inside the subroutine again. Now we are inside the interrupt subroutine, and you can see in our int main we don't print out that message. This message is only printed out in our subroutine here. It's only printed out in our subroutine. So you can see certain directing in the main flow of our int main by using the interrupt mode. And there's one more thing that I want to pay attention. So for example, now we are inside the subroutine, and if I change my switch pattern, it doesn't reflect in the interrupt, but it reflects in the main loop in the main program. So what does it mean? Again, if I change my switch in order to jump inside the subroutine and then I change my switch, that the second interrupt signal was not handled by the subroutine program. However, it's recognized by the main program. The conclusion is that whenever we are inside the subroutine and we change our switch pattern, it won't be processed by our subroutine. It won't be processed by the subroutine. So that in the middle interrupt signal will be ignored. One more time, if we change the switch button, we are inside the subroutine, and if I change it when we are still inside the subroutine, that interrupt signal is ignored. Now let's change the switch button again and look in the SDK terminal. You can see we're inside the subroutine, and we wait for that one blink 5 times, and we are outside, and then we are back in the main loop in the main program. So you can see the redirect from the main program to the interrupt and go back to the main program where the main program left its operation. And I want to show one more thing. So the GPL 0 error is a shared variable, and I say I will change that value inside my subroutine. This is my subroutine connected to my interrupt ID, the interrupt connection signal between my XI GPL 0 and the processing system. So because there's no error, since the instance pointer of this interrupt subroutine recognized is the same with the GPL 0 as we expect, so there's no error. But I will put this line intentionally in order to modify a shared variable outside our main loop. So I will modify the GPL 0 error in this subroutine, but not in my main loop, my main program. There's no commands that I change the value of the GPL 0 error, but I will change it when we are inside the subroutine. So we will expect to see this message to be printed on our SDK when one interrupt signal is generated. Now I will save my code, Ctrl F, and then I will build my application, and I will launch it. And I'll go to SDK terminal. Now we are reading the switch value in our main program. You can see in the main program. Now if I want to generate the interrupt signal, I will change one of the switch. Now I'm inside the interrupt routine, and you can see now the message printed on our SDK terminal has been changed because we changed the GPL 0 error by generated the interrupt subroutine or the interrupt subprogram interrupt routine. And even if I'm gonna be inside the interrupt routine one more time, the GPL 0 error won't be changed, since it's always correct with this condition, because this condition always met, so our GPL 0 error always 1. That's why in the main program, in the while loop, we will always be here. Let's demonstrate it again. Now I will comment this one out. It means by default our GPL 0 error is 0. So in the main program, we will print out this message instead. Even if we're gonna generate our interrupt signal, this message won't be printed, since we don't encounter any error to change the value of the GPL 0 error. So it always stays 0. This condition always 1, always true. So we will always print out the value of the switch. on the SDK terminal. Due to the default setup of our shared variable GPL 0 error to be 0. Now I will build a program and then I will run it one more time. And go to SDK terminal. Now we read in the switch value because by default our GPL 0 error is 0. So we will always be printing this line in our main program. Now let's generate the interrupt signal. Now we are inside the interrupt signal and we can see that the LEDs blinking according to the switch pattern. Now we are outside and we still print the value of the switch in our main program because the GPL 0 error has not been modified by our interrupt signal, by our interrupt routine, because this condition is always correct. In this case, this condition is always correct, so we will never go into this line to change our shared variable or global variable GPL 0 error to be 1 to print the error. So that's the thing that I want to demonstrate, to see that whenever we generate the interrupt signal from the switch, our flow in the main program will be redirected to the interrupt or to the subroutine outside the main program. Do that subroutine, finish it, and then it will go back to where it has been left off in the main program and continue the flow. Thank you so much for watching.